In this case, we had a situation where the power equation was exactly solvable, so that you could obtain an expression almost exactly. The only unknown term was the h of theta. But in all problems, the power equations may not be solvable, and in that case may not be solvable because the number of equations might be smaller than the number of unknowns. When that happens, we normally try to express it in terms of one of the powers and express it in terms of just one unknown and then proceed. Let me illustrate that with an example. Suppose we consider the same problem, where we are trying to figure out, we do not know about the Newton's laws, and we are trying to figure out how far will a cannon's throw go, a cannon and it will go, but this time we consider the air friction suppose. So, when we try to do that, let us see how we can proceed using dimensional analysis. In the earlier part, we assume that the air friction is negligible, and after having done the derivation, we might perform the test and might find that it does have some effect, and therefore, that cannot be completely negligible, and so we have to derive the expression involving the air friction. How do we go about it? Again, we have to guess what does d depend on. So, again d depends on, we have to start from the start, we have to guess whatever it might depend on without any prior knowledge, and therefore, it might depend on the mass, it might depend on the angle, it might depend on the initial velocity, and it might depend on the force of air friction, that is a force. So, let us call it F, and of course, it will depend on G. So, these are the quantities we assume that it depends on, and so we again write the equation as d is some constant k times m to the power alpha, we wrote u to the power beta, we wrote g to the power delta. Now, we have to introduce this, let us call f to the power some other Greek letter, say epsilon, and then theta will again be a non-dimensional quantity, and therefore, it can take any transcendental functional form. So, this is the basic equation we start with, and then we cast it in the form of the dimensional equation. So, the dimension of d should be equal to the dimension of k, which we can ignore if we assume that k is non-dimensional. The dimension of m is m to the power alpha, dimension of u is L T inverse to the power beta, dimension of g is L T minus 2 to the power minus 2, it has to be square bracket because the dimension square bracket delta, then F is force is equal to mass into acceleration. So, m times L T half L T minus 2 to the power epsilon, and h does not have a dimension. So, we can ignore that. We can write h of theta, but then we have to ignore that. So, this is ignored. because it is non-dimensional, not ignored, it is non-dimensional. Similarly, this is, we assume that this is non-dimensional. So, then the dimension of D is L, dimension of M is M, M to the power alpha. Here it is L, so we need to work out this M to the power alpha, L to the power beta, L to the power delta and L to the power epsilon. So, L to the power beta plus delta plus epsilon, T to the power minus beta, T to the power minus 2 delta, T to the power minus 2 epsilon. So, T to the power minus beta minus 2 delta minus 2 epsilon. Is there anything else we missed? No, we have missed something. Here is M, M to the power epsilon. So, to the power alpha plus epsilon. So, M here also. So, now we need to do a dimensional, write down the dimensional equations. There is no M in the left hand side. So, alpha plus epsilon should be equal to 0. There is an L with power 1. So, beta plus delta plus epsilon should be equal to 1, and there is no T in the left hand side. So, all these are minus. So, we can write at plus minus beta plus 2 delta plus 2 epsilon is equal to 0. Okay. Now, I can see that from these two equations we can extract the value of beta. All that we have to do is to multiply this equation by 2 and subtract from here. So, if we do that, it is this becomes 2 beta plus 2 delta plus 2 epsilon is equal to 2, and this one is beta plus 2 delta plus 2 epsilon is equal to 0, and if you subtract, this cancels off. This is beta is equal to 2. Okay. So, we get beta is equal to 2 without any difficulty, but we cannot get the rest because there are how many unknowns? Alpha, epsilon, delta, 3 unknowns, and we do not have as many equations, and so we have what remains in the equations after having obtained beta is that alpha plus epsilon is equal to 0 and beta is there. So, this equation becomes 2 plus delta plus epsilon is equal to 1, and this one also gives the same equation. Okay. So, we have alpha plus epsilon equal to 0. This we now express everything in terms of one of these unknown quantities, and suppose that unknown quantity is epsilon. So, in that case we have to express alpha as minus epsilon. From here we get delta is equal to delta is, this is minus 1 minus epsilon. So, minus 1 minus epsilon. we have obtained this, beta is known, alpha is known, delta is known. So, everything is known, fine. So, let us now substitute. Okay. So, we substitute into this equation, so that let me put some lines, so then we can work it out here. We can write d is equal to k times m to the power alpha, and alpha was minus epsilon. So, m to the power minus epsilon u to the power beta, and beta is known, beta is 2, g to the power delta, g to the power minus 1 minus epsilon, f to the power epsilon, and h of theta. So, now we have been able to express it in terms of just one unknown power, and if you just rearrange it a bit, if we rearrange it a bit, it becomes k, well, put all the epsilon terms in one place and non epsilon terms separately. So, this becomes u square g to the power minus 1 e square by g, and then all the terms with epsilon put together becomes f to the power epsilon by yes m to the minus epsilon. So, m in the denominator, g in the denominator, to the power epsilon times h of theta. Now, you notice that this is to the extent that dimension analysis can bring us, but we can go a little more further. I can see that, because f has a dimension of f is sorry, I have to write in capitals, m l t minus 2, and the dimension of m g should be m g is also l t minus 2. Therefore, they have the same dimension. Therefore, f by m g is non-dimensional, and if f by m g is non-dimensional, there is no reason to expect that it will take only a power. A non-dimensional quantity can take any transcendental functional form without any difficulty. Therefore, we can and should write d as something that we have actually derived from the dimensional analysis positively, is this part. But we now notice that this quantity and theta both individually are non-dimensional quantities, and therefore, there can be some kind of a functional form, involving f by m g and theta. This has to go together, because it together is non-dimensional, and therefore, it will be a function, a transcendental function of two variables. One variable is a composite variable that ultimately totally is non-dimensional, and theta is non-dimensional. So, this is how we write the equation. This is as far as the dimensional analysis can bring us, but you can immediately see that this points to a way of conducting directed experiments to obtain that functional form. Okay. In that case, we will do something so that we will use the same velocity and maybe keep this also constant and vary only this, thereby get different distances and draw a graph that will give us the dependence on theta, and similarly you keep theta constant, u constant, and throw with different masses, and you will then get different values of this, and you will get from these two you will get a functional dependence on both these quantities. This is a way of obtaining a mathematical model without any use of a theoretical background. We have not used theory anywhere in this method. The resulting models are normally called the phenomenological models. A phenomenological model is where something that does not contradict existing theory, but is not derived from existing theory. It is derived from something else, some other consideration, not from the first principles. What we did in the last class was to derive from the first principles, but a phenomenological model is derived not from the first principles, but it should not contradict what is already known. And the models like this that are derived by the method that I have just shown are a typical examples of phenomenological models. Remember, the word phenomenology has different connotations in different fields. For example, in particle physics, phenomenology would mean deriving experimentally testable predictions from existing theory. Supposing there are a few competing theories in place for a particular experimental situation, what will be the prediction of this one, what will be the prediction of that one, obtaining that is said to be doing phenomenology in particle physics, but a phenomenological model is something else. And also in philosophy, phenomenology concerns how we think and all that. We are not talking about that. Phenomenological model is a model that is not derived using existing theory, but that does not contradict the existing theory. Okay. So, these are ways of obtaining some phenomenological models, and once a phenomenological model is derived, the theorists will get busy in trying to figure out why this particular functional form. So, this is how science progresses.